Hello, learners. Our topic is all about algebraic expressions. When we say algebraic expressions, it is any combination of one or more constants and variables along with at least one mathematical operation. We have here some examples of algebraic expressions. 70R, it is a combination of a number, a constant, and a variable. And the operation here is multiplication. We also have here 3x plus 2. We also have the third example here. We have 3x divided by y. 1/2 base times height, x plus 4, and 3z. And as you can observe, it is actually the combination of one or more constants and variables. And these expressions here, these examples here, have at least one mathematical operation. And when we say mathematical operations, we are referring to the operations addition, subtraction, multiplication, and division. Now let us define what are variables and constants. So when we say variable, it is any symbol representing possible values of a quantity. Lowercase letters of the alphabet are used to represent variables or unknown quantities. So sa mga expressions natin, we usually use the variables x, y, z, s, and t, m, n, and so on. And those are the letters of the alphabet. And take note, it should be in lower case. And again, when we say variables, those are unknown quantities. Now, let's proceed with the constants. A constant is any symbol representing one fixed value. Numbers are also called constants. So basically, those constants are the numbers in the real number system, because the value of a number, of any number in the real number system, cannot change. It is constant. It is consistent. For example, we have the number 5. Number 5 is always number 5. Wala siyang ibang value. Fixed na 5 yung number na yun. That is why it is called a constant. Now, sometimes we also use the letters A and B to represent constants. But now, let us proceed and let us define what is a coefficient. Here we have a coefficient is a number used to multiply a variable. An example we have here is 4x. It means that 4 times x. So 4 here is a coefficient. Now, if variables on their own, if they have no number next to them or beside them, it actually has a coefficient of 1. For example, we have the variable x. Actually, again, it has a coefficient 1. So therefore, x is really 1x or 1 times x. And sometimes, a coefficient is a letter like A or B instead of a number. For example, we have here a quadratic expression, ax squared plus bx plus c. X is the variable, a and b are coefficients, and c here is a constant. So again, when we say coefficient, those are numbers beside a variable. Now, we have here another example. 4x minus 7 is equal to 5. The coefficient here is 4. The variable is x. The operator is subtraction. The constants are 7 and 5. Now, when we say a term, it is an expression preceded by a plus or minus sign, meaning the plus or minus sign serves as a wall to the terms to separate them. For example, we have here x plus 2. So we can identify the terms by just breaking down or by just separating those terms or those numbers, variables that are that are separated by the plus or a minus sign. Here we have the plus sign, therefore we will separate x and 2. Hence, for this example, we have two terms. The first term is x, and the second term is 2. Take note again, you can only identify the number of terms by just identifying those expressions preceded by a plus or a minus sign. So now let us have the polynomials. A polynomial can have constants, variables, and the exponents 0, 1, 2, 3, and so on. But it never has division by a variable. Here we have 5xy squared minus 3x plus 5y cubed minus 3. So we have here 4 terms because 5xy squared is separated by a minus sign. Okay, separated siya kay 3x. And also 3x is separated kay 5y cubed by a plus sign. And 3 is separated by 5y cubed by a minus sign. So we have 1, 2, 3, 4 terms in total. And this is an example of a polynomial. And those who has negative exponents or those fractional expressions na yung variable ay nasa denominator, those are not examples of polynomials. Okay? Again, those who have negative as their exponents, variable na negative yung exponents, and those fractional expressions or rational expressions na yung denominator ay merong variable are not example of polynomials. So now let us proceed and we will discuss the 3 types or 3 classification of a polynomial. We have the monomial, binomial, and trinomial. So these are special names for polynomials with 1, 2, or 3 terms. A polynomial with 1 term is called a monomial. For example here, 3xy squared. A polynomial with 2 terms is called a binomial. And we have an example here, just like 5x minus 1. And last, a polynomial with 3 terms is called a trinomial. And our example here is 3x plus 5y squared minus 3. Now, those are special names for polynomials with 1, 2, or 3 terms. What if the polynomial has 4 or more terms? If that's the case, then they are just called polynomials. Again, if that's the case, then they are just called polynomials. Only a polynomial with 1 term, 2 terms, and 3 terms have special names. Now, what about like terms? Let's have here, like terms are terms whose variables and their exponents, such as the 2 in x squared, are the same. In other words, terms that are like each other. Note the coefficients can be different. So again, we can consider the terms as like terms if they have the same variables. Okay, so for example, the given term has the variables x and y, and another term has the variables x and y. And if their exponents, the exponents of the variables are the same, therefore they are like terms. Again, to be considered like terms, they should have the same variables and the same exponents. And take note, coefficients can be different. So we have here the examples: 1/3 xy squared, negative 2xy squared, and 6xy squared. And these terms are all like terms because the variables are all x and y, with the y na merong exponent na 2. And you can observe here, and you can see here naman, you can observe that they all have the same variables x and y, and yung y merong exponent na 2. And now, let's proceed with identifying the degree of a term. The degree of a term is the sum of the powers or the exponents of each variable in the term. So you can identify the degree of a term by just adding all the exponents in the term. Okay, the exponents of the variables in the term. So for example, we have here, identify the degree of each terms of the polynomial. So we have here the first term. Okay, so we have here the first term, negative x cubed y squared. The second term, 2xy squared. And the third term, negative 5x plus 4. Now, the degree of the first term, we have here the exponent of the variable x is 3, and the variable y is 2. Therefore, to find the degree of the first term, we will just add 3 plus 2. Then we have here the answer. The first term of the given polynomial is on the 5th degree. Now for the second term, the exponent of the variable x is 1, and the variable y is 2. Hence, the degree of the term is 1 plus 2, which is equal to 3rd degree. Now let's proceed with the third term. We have here the exponent of the variable x is 1. Hence, the degree of the term is 1st degree. So the third term is on 1st degree. And the degree of the fourth term, the term contains no variable. Hence, the degree of the term is 0. So all constants, okay, their degree is 0. So that's it. That's how you identify the degree of the terms. You just need to add the exponents of the variables in that term. And now, with all the if you have identified all the degree of the terms of each terms, we can identify the degree of a polynomial. The degree of a polynomial with 2 or more variables is the highest degree for a term with non-zero coefficients. So for that example, the example we have earlier, we have negative x cubed y squared plus 2xy squared minus 5x plus 4. The degree of this polynomial is 5th degree. Why? Because the term with the highest degree, as we have identified earlier, is the first term, 5. Because second term is only on the 3rd degree. The third term is on the 1st degree, and the fourth term, or the constant here, is on the 0th degree. Okay? 0 yung kanyang degree. Hence, the degree of the polynomial is on the 5th degree. That's it for the algebraic expression.